Okay, today in class we did mole two-step problems. And so our little thing is go for the mole. The way you're going to know you're going to need to go to the mole is as you read the problem, if the word mole is not in the problem, you're going to have to go to the mole first. It's our base unit. It's kind of like when we went from centimeters to kilometers, and I made you go to meters first. So if we have grams, and we're trying to get to like atoms, molecules, or formula units, then you're going to have to go to the mole. And from the mole you can go to atoms, molecules, formula units, things you can count. Or if you have atoms, formulas, molecules, and you're trying to get to grams, you have to go to the mole. And then from the mole you can go to grams. So it's going to make it a two-step problem instead of a single problem. So let's begin. I've got 3 examples for your notes today. So it says how many grams are in 3.5 times 10 to the 25th formula units of iron 3 sulfate. So as I read that problem, nowhere in this problem does it mention mole. And because of that, I know it's going to be a two-step problem. What that means is I'm going to first go to the mole. So we're going to start out with our number. Our unit right behind the number is formula units. And then it's iron 3 sulfate. Now iron is telling me to use it as a positive 3. Sulfate is SO4 to poly to minus 2. So our formula, we're going to switch them, is Fe2 parentheses SO4 close the parentheses 3. Now this is going to get a little big, so I need to start writing smaller. So we're going to bring formula units down, and then we're going to always put our label. You'll understand when we get to stoichiometry. And because I don't see the mole, I'm going to go mole here first, and we're going to write the label. Fun down to the mole. I don't want mole because I am looking for a gram. That's what I'm wanting. So I'm going to bring mole down, and I'm going to bring gram to the top, and they both get our label. Everything's getting our label. Again, you'll understand when we get to stoichiometry why that's so important. So formula unit down to the mole, to the mole, to the gram. Now mole always gets a 1. There's my mole until we get to stoichiometry. And then now we're going to use either Avogadro's constant, which we're not going to ever put next to gram. So we're going to put Avogadro's constant here. I did not leave myself much room. Make sure you put parentheses if you're using those smaller calculators. And then we're going to use molar mass here. And I'm going to do the molar mass up near the top because there's more empty space. So we're going to come up here and we're going to list our elements. We have iron, we have sulfur, we have oxygen. There are 2 iron, and we'll multiply. There are 3 sulfurs, and there are 12 oxygens. We go to the periodic table. You get 55 point. Most of the periodic tables say 8, some round to 9, depending on your periodic table. You get 111.6. This one rounds to 32.1, and you get 96.3. And then oxygen 16, you get 192. And we add all these together, you get 399.9, and then that's going to go with our grams. Multiply across the top, divide by our bottom, multiply, multiply, divide. And your calculator is going to give you 23,250. So you can round this to significant digits to 23,300 grams, or you can do scientific notation if you prefer. It doesn't matter to me. I would like the correct amount of significant digits though. And so either one of these are good answers. Alright, so it shouldn't be too much harder. Alright, let's look at the next one. Oops, wrong button. How many formula units are there in 8.5 grams of silver nitrate? And then how many oxygen atoms would there be? Silver's a positive 1 and nitrate's a negative 1. So our formula is going to become AgNO3. Okay, so we have 8.50. Our unit is grams of silver nitrate over 1. Bringing grams down. As we read the problem, there is no mole, and I can't go from grams to formula units. So I'm going to put mole here. Grams down, mole. I don't want mole, so I'll bring mole down. And from the mole, I'm going to formula units. And again, the reason it's formula units is because it's an ionic compound. So it's just a word we use for this many moles will be this many compounds. Alright, grams down to the mole, formula unit. Every time I see mole, mole gets a 1. Using Avogadro's constant and molar mass, we can't use Avogadro's constant with grams, so we're using Avogadro's constant with our formula units. With our grams, we always use the molar mass. So we have 1 silver, 1 nitrogen, and 3 oxygens. Silver is 107.9, and I would multiply. Nitrogen is 14, and oxygen is 16. I do need to remember to multiply that by 3 to get 48. And then you're going to get a total of 169.9, and that's going to go right here. So, can you see that cancels, and you're left with formula units. Multiply, multiply, divide, and you will get an answer of 3.01 times 10 to the 22nd formula units of silver nitrate. The second part of that question says how many oxygen atoms are there? Well, here's our formula, and every formula unit of this, there are 3 oxygen atoms. So I need to multiply the fun by 3. Well, this is not the fun. 8.5 grams is not the fun. Here's the fun. So we're going to multiply this by 3, and we'll get 9.03 times 10 to the 22nd oxygen atoms. So always your molecules or your formula units by how many are in 1 to find those individual atoms. Alright, last example is going down here, so let me scoot this up a little bit. It says if you have 4.5 times 10 to the 24th molecules of dinitrogen pentoxide, covalent, using the word molecule, so I don't need to switch them, just write what it says. It says how many oxygen atoms are there? Well, for every one of these molecules, there are 5 oxygen atoms, and I know how many molecules. So to answer that first question, I don't have to do anything special other than take my molecules and multiply by 5. If I were doing nitrogen, I'd multiply by 2. So we get 2.25 times 10 to the 25th oxygen atoms. Alright, so we answered first question. Next question says, how many grams of dinitrogen pentoxide would there be? So I've got to go back to my original, which is 4.5 times 10 to the 24th molecules of dinitrogen pentoxide. I'm going to bring molecules down. As I read, nowhere is the word mole, So mole's coming into the equation. And on these two steppers, mole will always be right there. We're going to then bring mole down. And from the mole, you can go where you want to go, which is to grams. Every time we have mole, it gets 1. We have two choices, Avogadro's constant and molar mass. This will get Avogadro's constant because it's not grams. And then with grams, we'll do molar mass. There's 2, and there's 5. Some of them are whole numbers, and so this one has both of them as whole numbers. Makes it kind of nice. So it makes it 108. I'm going to stick that up here with the grams. It is grams per mole. You can see grams mole. So now I'm going to multiply the top numbers, divide by my bottom number, and this one you get a total of 187 grams of dinitrogen pentoxide. So I've answered that question, and up here, to get those individual atoms, when we're talking about a compound, you need molecules or formula units. If this had said atoms, I would not need to do any multiplication because it would have been. So that's pretty much the 2 steps. So hopefully this video has helped you a little.